This video will look at total quality management and quality tools. It's one of a series of videos on this topic, so there are several listed in the notes, and you should really make an effort to look at all of them and make notes from them. Don't just look at them, but actively make notes. Stop the video, make notes, wind it forwards, wind it backwards, and so on. However, let's move on in our consideration of TQM and quality tools. For a start, total quality management is a philosophy that involves everyone in an organization in a continual effort to improve quality and achieve customer satisfaction. So that's what it is. It's trying to involve everybody in the organization and every part of the organization in a way that will continuously improve quality and also to achieve customer satisfaction. And of course, both of those are linked. And that will be to the advantage of the organization. Once it has a reputation for good quality, it will be in a better position to compete in the marketplace, take on its competitors and beat them. And it also has a better chance of surviving into the long run. So the emphasis on quality is not just an empty aspirational objective. It is something which is extremely important for the reputation of the business, for sales, for growth, and for the continuation of the business. So we're emphasizing continuous improvement and the involvement of everyone and customer satisfaction. So there are three big components in total quality management. Trying to continuously improve the processes within the organization, continuously improve the product that's being produced, the involvement of everyone from line operators, line management, middle management, senior management, the office staff. Everyone is involved in the process of continual improvement, and it's all targeted at customer satisfaction. So customer satisfaction will have been determined by the marketing department, and or will hopefully have been determined by the marketing department. Customer requirements will be noted and listed and so on, and the objective of the business is to meet those requirements and give the customers high levels of satisfaction. So what we need to do is find out what the customers want, and this, as I said, is the function of the marketing department. But try and find out precisely what they want and what would give them high levels of satisfaction. And then design a product or service that meets or even exceeds customers' wants. Don't just meet the customers' wants, if possible exceed it, so the customers are pleasantly surprised, they're amazed, they're happy, and the business will gain a higher reputation as a consequence. Design processes that facilitates doing the job right in the first time. Don't try and just design processes and watch out for errors and mistakes and try and correct them. Try to get it right first time, because otherwise there's a waste of resource, there's a waste of time, there's a waste of materials. It's important to try and get the situation right the first time. The term often used here is poka-yoke, and poka-yoke is mistake proofing, trying to eliminate mistakes. Poka-yoke. Keep track of the results. Keep good records, so efforts are not duplicated unnecessarily and efforts are not wasted. So keep good track of results. And extend the concepts to the suppliers if possible. Try and get the suppliers to deliver good quality raw materials and components. Good quality and on time, precisely according to the schedules that have been given on the day. Now, elements of TQM, well, as I said, continual improvement. Now, we'll talk about Kaizen later. I'm just putting the word there for the moment to familiarize you with the word. We'll come back to it in a separate video. It's an important issue and one that needs a bit more care and attention. But I'm not going to get into it here. I'm not going to talk about it. I'm just going to say continual improvement, Kaizen, and we'll leave it at that. The commitment of the organization is to continually improve the processes and continually improve the product. And competitive benchmarking. Look at what competitors are doing. Buy their products and dissect the products. Look at them in detail and see what the products are like. And try to benchmark the products of the business against the competitors. But try to beat them in quality. Try to beat them in terms of efficiency as well. Try to sell it at a reduced price if possible, but a higher quality so the customers are pleasantly surprised. Employee empowerment and quality at source, with each worker responsible for the quality of his or her own work. Try to delegate the responsibility down to the individual because they will be more motivated. They're responsible for that section and they will feel more engaged. They'll be more interested in quality and in achieving the targets. So employee empowerment is a part of the process, making the workers feel that they are contributing to the overall process in building a quality product. Have a team approach if possible with a quality champion. Build teams that are focused in on qualities and have a quality champion. Have a spokesperson within the team who will organize the team and have small meetings from time to time and pass information around between the team and feed back any issues to management, to their line manager or whoever. And in this way, everyone's involved in the whole process of trying to improve the product. And make the decisions based on fact. Don't just make it up or think what the situation is. Don't imagine the situation. Try to base it on fact if possible. Try to measure. Perform metrics. Get measuring tools and measure the problem and see what variations there are and bring back real issues to be dealt with. Have good knowledge of the tools. It's important that in the whole process the limitations of the machines and of the equipment are known and factored into any calculations. It's pointless setting benchmarks and targets that cannot be achieved by the tools available. So it's unrealistic to expect workers to achieve certain levels of output if the machines they're working with are not capable of delivering that. So knowledge of the tools is important. And link knowledge of the tools to quality to make sure that the tools are capable of delivering quality products to the tolerance levels that are being set and make sure that they meet benchmarked requirements. Supplier quality and supplier involvement. Try to build in the opinions and the ideas of the suppliers. Try to involve them. Try to make them see themselves as part of the overall process as well. They're supplying raw materials. They may be supplying it to many people, but make them feel important. Deal with them as suppliers who are important. Try to get them to deliver on time, quality the product that meets the requirements of the business. So it's linking the whole thing together. Now there are obstacles to implementing TQM. For example, the lack of company-wide definition of quality. People need to know what quality is. It sounds easy in some respects. We take the customer requirements. The marketing department asks the customers what are their requirements and try to list the requirements. But sometimes there's vagueness involved. Customers might say, well, we want products that are high quality. That's a tautology. That's just defining quality with quality. So it's difficult sometimes to get a proper definition. Sometimes what we're aiming at is a feeling of better quality, but try to make it as objective as possible. Look at the strategic plan and build in change into the strategic plan, that this whole process of continually looking at the business and striving for quality and continual improvement, that is built into the strategic plan. So the whole organization is behind the initiative to try and improve quality. And look at the resistance to change, because that's an obstacle to TQM. People like to continue doing what they're doing. They're used to it, they're familiar with the whole process. They don't want change. People resist change. They like a routine. So how can the resistance to change be overcome? How can management deal with that? Have a customer focus. Look at the product from the customer's perspective. Try to imagine what the customer will feel about the product when he or she gets it. Are expectations met? Are they likely to be met with that particular product, the one that's been made? What issues remain that need to be solved? And try to look at those issues from the customer's perspective. Are they important issues? When the customer gets the product, they should be amazed. They should be delighted with the product. Real employee empowerment and motivation. Well, trying to get the employees to be involved and to be motivated may be a problem. It may be an obstacle. Some employees may be looking at their own lives and the fact that they're going to retire in a couple of years' time, and therefore they're not prepared to participate wholeheartedly in some big new initiative about quality. They would just want to carry on as they were doing before. There might be issues like this. And how are these dealt with? And how to get employees responsible for their own tasks and the quality of what they're doing. What incentives could be used? There's also red tape. Red tape means bureaucracy. There are always issues, and sometimes people can slow down the process by engaging in red tape, having long meetings and many meetings, and people get fed up after a while. They're bored. They're continuously talking in circles, and there's no movement. There's no activity. So it needs strong management to cut through the red tape, cut through the bureaucracy, and tell people to get on with doing this and bring back results or bring back ideas by next Friday, and have a meeting on Friday and discuss those ideas and move forward. All the time moving forward, not talking in circles and looking for problems and trying to solve problems that don't exist. Don't anticipate problems and imagine problems that are simply not there, just for the sake of talking. And the time to devote to quality issues is always precious. Most times people within the business are trying to make products that meet current customer requirements, current customer demands, trying to meet orders that are on the book right now. And that means they haven't got time to deal with quality issues and be involved in big initiatives and retrain and do all sorts of appraisals of their equipment and of themselves and reorganize the production facility. They haven't got time. They need to complete the orders that are on the books right now. So there are issues involved here, and management needs to find a way to think forward, to introduce TQM, whilst at the same time enabling current production to continue. It might be just down to leadership. The introduction of TQM needs a champion, needs somebody within the business who is going to lead the charge into TQM, is going to lead the initiative and get it established. They need to have a plan for the establishment of this type of philosophy at work. And the plan should be realistic and paced appropriately, not rushed into. there needs to be training. There needs to be commitment. The advantages of the policy needs to be explained and clearly understood by everyone. So it needs leadership. Criticisms of TQM. Well, it has its criticisms. Sometimes there's a blind pursuit of TQM. It's just TQM, TQM, TQM. It's everything runs to TQM. It's important to meet current orders. It's important to be human about the whole process and to realize that some situations there might be variation and there's nothing can be done about it. And the quest for absolute total quality is illusory within certain organizations. It can't be achieved because certain processes have to be made in a certain way, and it's inevitable that there will be some degree of variation. But blind commitment to TQM would then just lead to hold-ups and unnecessary meetings and monitoring, and so realism has to be fed into it. Common sense needs to be applied as well. Sometimes the TQM programs and procedures are not linked to strategies. They seem to be just something that's happening within the organization. There's commitment, and it's been put through. There is a commitment to that particular policy. But it's not necessarily linked to the strategies of the business, to the strategic plan of the business, to the marketing plan, or to the business plan in total. It seems to be just something that's bolted on. It's an addition, and that's not right. It needs to be integrated, and its implications and its requirements should be understood within the context of the overall activities of the organization. Failure to carefully plan a program and the resources necessary to implement TQM. Planning TQM programs, difficult. There needs to be good understanding of each of the processes and how the processes are linked one to the next, right from the time the raw materials comes in to the time when the products are dispatched to the customer. There needs to be very clear understanding of each of the processes and their requirements, and then to get involved with each of the processes to ensure that each process is structured in a way that will maximize the quality of its output. So it's difficult to implement. It's difficult to even see sometimes. So it depends on the product, it depends on the company, of course, but there are issues there. We come across this idea of what's known as 6 sigma. Now try to imagine a normal distribution curve for those of you who have done statistics. And if we take 1.96 standard deviations either side of the mean, we pick up 95% of the probability that a sample will fall within 1.96 standard deviations away from the mean. If we work out the standard deviation of the sample, 1.96 thereabouts on either side. So we'd have a plus and a minus figure. Well, 6 sigma is using this type of concept. If you're not familiar with statistics, don't get put off by what I just said. What I'm trying to drive at here is 6 sigma is a very strict view of quality. A business process for improving quality, reducing cost, and increasing customer satisfaction. That's what Six Sigma is about. It's about improving quality, reducing cost, and increasing customer satisfaction. So no one can fight with those 3 objectives. Statistically, it's having no more than 3.4 defects per million. So if the company makes 1 million items let's say a week, a million, it can't have more than 3.4 defects. That's a very small number of defects. That's what is meant by Six Sigma. That when the company is producing, it's almost perfect. Every item is almost perfect. It's only 3.4 defects per million items produced. And of course you can scale that down. If a company is producing 1,000, just divide it out by 1,000 and you'll see how many defects. It's minuscule. It's very small. There's no tolerance or toleration. Sorry, there's no toleration of defects. Six Sigma is almost perfect. It's practically perfect. So there are no defects in production. Everything is produced to a very, very high quality standard. So conceptually, the program is designed to reduce defects. Requires the use of certain tools and techniques. So it does have to be applied, this idea of Six Sigma. But the idea is to reduce defects. So it's to improve quality. That's what the Six Sigma programs do. Improve quality. They try to save time because there's no going back and trying to fix the defects or find out what happened, because there aren't any. Or there are so few, they're negligible. They're just bad luck almost. 3.4 defects per million. That's as near to perfect as almost you can imagine. So it cuts the cost. There's no wasted raw materials and no wasted time in production and going back to fix the problem. So it should cut the cost. The emphasis on quality here is cutting cost. It's implied in all sorts of places. In design, production, services, inventory management, in delivery. So this idea of Six Sigma, of trying to eliminate defects, cuts right across nearly all aspects of the business. If it's a production business, in design, in the service it delivers, in the inventory management, there are no defects, there are no mistakes, there are no errors. They're almost eliminated. Now the components, well, providing strong leadership, that's very important. The whole idea is to try and produce the product without defects. So strong leadership is required. It has to define performance. The performance has to be defined, and the merits of good performance have to be pointed out. The advantages of good performance have to be pointed out and understood. But performance itself should be defined. What is good performance? What is good quality? What is good procedural management? What is it that enables the production to take place without any defects? Selecting projects likely to succeed. Well, some projects will have issues and will have problems, and it may be difficult to aspire to the Six Sigma ideal. So it's important to select the projects that are likely to succeed. Otherwise, a lot of frustration and time and effort will be spent, perhaps wasted, on areas where there is, in a sense, natural variation. An example jumps to my mind here immediately of, let's say, agriculture. We have an idea of what a good quality apple is. Well, apples on trees come in different sizes and shapes. And that's the way nature intended, and that's the way it should be. So maybe trying to standardize the apple into a certain weight before it's picked, the effort in doing it would be ridiculous. So it's important to select the projects that are suitable for Six Sigma. The technical components, well, improving the process performance. It's important to make sure all the processes are aiming at total quality. In other words, they're looking at no defects. It should reduce the variation. In a separate video I talk about control charts and looking at variations and how management tries to reduce the variation of the product, the quality of the product and of the technical aspects of the product to make sure its dimensions are within certain tolerance levels. But try to reduce the variation, because that means the company is focusing in on the ideal product, one which is perfect quality and therefore will meet the Six Sigma ideal. Try to utilize statistical models where possible. Try to take measurements. Use metrics. Try to take measurements and look for variations based on fact. Try to be as objective as possible. Designing a structured improvement strategy. Try to set out a strategy that will continuously improve output and quality. Not just a strategy to get the work done, but one which will get it done with continual improvement to the quality. The continuous application of techniques and monitoring to output that will indicate it's of a certain quality and it's acceptable. There should be no variations. There should be very little variations at least. So in the manufactured sense, forget the agricultural one I just mentioned earlier, but in the manufacturing sense, it should be manufactured to perfect quality if possible. So the components, well, strong leadership. It's important that someone drives this initiative. Somebody is on top of the situation, somebody that the workers respect and management respect, and someone who's going to try to implement this policy. It's a very strict policy, almost no defects. It's important to define performance merits, define what's gone right, and congratulate the people who got it right, and try to look at what best practice was and try to learn from that and maybe implement it elsewhere if possible. But looking at what determines the performance and try to improve the performance, and then when it's working to almost no defects or no defects, then try to implement similar strategies if possible elsewhere. It depends on the product, depends on the company. Select projects that are likely to succeed, as I said earlier. It may not be suitable for all projects. Some projects may have artistic components or require manual workmanship and so on, so there might be some variation. Make sure that people are selected and trained to be familiar with the requirements of Six Sigma, and they will engage in the efforts to try and achieve Six Sigma. They will try to achieve no defects. Well, the team should be, of course, top management. They need to be committed. If they're not committed, no one's going to take it seriously. So it has to be top management. Product champions, people who know particular products and know everything about the product and know how to make the product and the ups and downs of making the product, the issues and so on. So product champions, people who push the importance of certain products. Then we have terms like master black belts. These are people who are particularly keen on Six Sigma and understand all the issues and can fix problems and can motivate the workers and can come up with designs for the product and for the production system which will enable it to happen. These are very committed individuals, committed towards the achievement of Six Sigma. These are called black belts. They play a pivotal role. They're very important in the overall achievement of this type of outcome, an outcome which meets the Six Sigma requirements. Implementing process involvement projects. Facility change, convey knowledge to green belts. So the facilities may change, the production systems may change, the machinery may have to be changed, the layout may have to be changed. So there are issues of change management here. But the black belts, in the sense they are so committed and they understand the system so well that they become natural leaders, and people will follow their example because they are so capable themselves of producing to the standards that they're talking about. And they convey this to what's known as the green belts. The green belts are the people who are going to learn about the whole procedure and eventually implement it. But they need to be guided and directed and supported by the black belts. The black belts are the ones who are pushing it through. The green belts are the ones who are going to learn and use it. But they're also committed. They're committed individuals to it. It's just that they're at an earlier point in development than the black belts, a much earlier point. So as a part of the team, we'll have the black belts and we'll have the green belts. And then we have, of course, the Six Sigma process. And the Six Sigma process is the whole team that are committed to the process of implementing this zero defect mentality. And there's often talk in the literature about what's known as define, measure, analyze, improve, and control. That approach is the one that may be followed in the context of Six Sigma. Defining the problem, measuring it, analyzing it, improving it, and then controlling it. Now, the basic steps in problem solving. Well, define the problem and establish an improvement goal. So if there's a problem, it's necessary to define the problem, to understand the problem, and then find an improvement goal. Find something that that will replace the existing goal with something which is better. So define any problem and then look for some ways of improving the situation. Ideally improving the quality of the product and the process. But that might involve retraining the individual who's involved, or retooling the machine, or updating the machine, or there might be some aspect of wider investment involved in order to get the improvement goal. Collect data. It's very important. If there's a problem, what is the problem? How is the problem manifest? So collect some data. Then analyze the problem. Look at the data, analyze the problem. Use some statistical techniques perhaps, but get some sort of handle on the problem. Try to understand the nature of the problem based on the data that was collected. And then from the analysis generate some potential solutions. Try to solve the problem based on analysis. And from the various solutions that could be identified, select one. Select the most appropriate. And make sure it is the best one. Maybe have discussions with others and talk to management and talk to the operators on the shop floor and talk to various people about the various solutions and which one is most appropriate. And then implement the solution. Having selected it, it's important that it's implemented. Otherwise it's just a solution on paper and doesn't do anything. So it must be implemented. And then monitor the solution to see if it accomplishes the goal. Once it's implemented, keep checking to make sure that the improvement that was anticipated actually comes about. Now, having said that, we can move to one particular view of this, which is the PDSA cycle. Well, PDSA simply stands for Plan, Do, Study, Act. Sheworth cycle, or the Deming cycle as it's sometimes called. The idea is to plan, to do, then to study what you've done, and then act. So we'll just go around the circle to see what's done. So with plan, document processes, collect and analyze data and develop a plan. So the plan is born out of data that's collected, and through some sort of analysis of the data, the plan is developed. Then implement the plan and collect more data for evaluation. So implement it and see how well the plan is working. Using data to check results match with the goals. So compare the outcomes from the implementation stage. Compare the outcomes with what was anticipated to see if they match. And standardize successful methods or revise unsuccessful plans. So if the results were not good, go back to the plan and do it again. If the plan was good, then standardize it. That's fixed. That problem is fixed. Implement it and move on. You might be able to take this whole process and go to the next process and use the same PDSA type thinking and look at it elsewhere. So this Deming wheel is a short way of looking at problem solving and implementation of solutions, and then monitoring and moving on to the next problem, and perhaps implementing the similar type of methodology. Having said all of that, of course, all of this needs to be done on a continuous basis. The commitment from Total Quality Management is that there is continual improvement. So there's constant scrutiny of all the parts and how they're working and the outcomes and so on. So it's a continual process. Now, process improvement and tools. Well, take a systematic approach. The process mapping. Look at a flow chart. Look at the way the process is set up. Which process comes first? Which one comes second? What's the requirements before the second one can follow the first one? What's the quality? How is it checked between the two processes? Look at how the whole process is mapped out. Have a flow chart. Analyze the process. Are there too many steps in the process or too many? Is the production process very long? If it's very long, there's more opportunity for it to go wrong. If it's short, then it may not be capable of producing quality, because each part of the process is doing many functions, and if it goes wrong, if one of the functions goes wrong, that whole batch is lost. So looking at processes, it's necessary to decide if it's too long, the process is too many of them, or there's too few. There has to be some sort of ideal. It depends on the product, and I suppose on a fair amount of common sense. It's necessary to redesign the process if there is an issue. It's necessary to be very critical and be very logical. What should the process be? The overall process. And the idea is to produce very high quality with no rejects, 6 Sigma. Very, very high quality products. And that means having thorough knowledge of the product and of the processes, and trying to design a very logical and rational process. So a wide degree of consultation with experts and practitioners, people on the shop floor, engineers, even outside agencies, even people who produce machines or customized machines, to ensure that the right fit is achieved. Look at the tools for improvement. There are a number of tools that can be used for problem solving and process improvement, I should say. The tools can be statistical, looking at data and trying to get a statistical fix. What's the average number of failures? What's the trend? So it could be statistical, but it could also be observational, although it's a much weaker methodology, but simply by watching what happens. Sometimes in gaining efficiencies, watching it might be the best strategy. Having said that, to see what are the processes involved, and if the processes involved in setting up one particular machine, if they can be reduced or efficiency improved by reconfiguring the way the materials go to the machine or whatever. So sometimes it's by observation. Tools aid in data collection and interpretation and provide the basis for decision making. So it's important to have good quality observations or data collection systems, and information fed back from the various processes, production processes, should be treated seriously and subject to analysis and discussion, and will help in the overall thrust towards improving quality. Let's move to the process improvement cycle, and we'll finish on this one. We select a process that's going to be analyzed, and we're going to look at the efficiency of the process and the quality of the outcome from that process. Then it's a question of study. Look at the documentation, look at the figures associated with the process, look at the data that the process has generated. So it's a question of studying the output or the outcome of the process. Then, no matter what the outcomes are, look for ways to improve those outcomes. Look for some ways in which the outcomes can be improved or altered in some way, made more effective, better quality, or perhaps more quantity at the same quality. So some improvement should be identified, and every effort should be made to try and identify improvements. When there's a feeling, or more than a feeling, when there's some idea that improvements can be made, then try to design an improved process. See what would be involved in trying to improve the process and get more quality, better reliability, fewer defects. The organization may be running to 6 Sigma, 3.4 defects per million, which is almost perfect. But can it be improved? So try to design improved processes. See if something can be done to further improve the process. Then, if it can, then implement the improved process. Now, this redesign of the process may involve experts, as I said from earlier on, from outside, from people who build the machines that the company is working with, from training people who are going to train the operatives to work differently. It can be all sorts of people. It can be the operators themselves who make an input and tell their experiences. And so once the redesign has taken place, then implement it. There's no point in doing the whole thing if it's not going to be implemented. It's an empty process itself if it's not implemented. There's no point in conducting the whole exercise. So the exercise is to try and improve the process, get better quality or get more of the output, or both. So implement it. Then evaluate the results after the changes have been implemented. Evaluate them, measure them if possible, measure them statistically if possible. So evaluate them, and evaluate them critically to make sure that the data that's picked up is accurate and realistic. Then document the evaluation. Document it so it can form the next phase of the evaluation, because total quality management, as I said, is continual improvement. So this document that's now been derived from the evaluation, this document can be the starting point of yet another evaluation of this process, perhaps undertaken at a later time period, but it can be the starting point so that the process can be looked at again to see if even further refinements can be introduced. So it's a continual process, and that document is available to help kick off the process next time round. And that feeds back to select the process. So we have this circle almost of continual improvement that simply goes round and round. Clearly for each process it'll run for a certain time period given the resources of the business and move on to the next process and the next process, but eventually it'll come back to that process again, and so on. The cycle will continue and they will continually try to find improvements. That's the TQM way. And the Six Sigma is just in a sense telling the operators and telling the management the requirements. 3.4 defects per million, which is almost nothing. But having said that, TQM would be no defects per million. It's even stricter still. So the idea is to get very, very high quality. Now that's all I'm going to deal with in this session, so I'm going to leave this topic for the moment and say thank you for watching.